Hello everybody, welcome back to my channel. Hope you're having a wonderful day so far. Today is February the 7th, Friday, 2025, and we are back learning some Python once again. Thank you guys so much for joining me on this Friday. Let's go ahead and get the stream loaded up here. Hey Mahan, welcome back. How's it going, man? All right. Hey Magnet, welcome back up. Welcome back. How you doing, man? It's good to hear from you again. Back-to-back days for you. Welcome. It's great to hear from you again. All right, guys. So we are continuing on with chapter 9 today in data structures and algorithms in Python. Uh, we are almost done with the chapter. We only have about 10 more pages. 380 to 395, 94. So 14 more pages. So I don't know if we'll be able to finish it today. It looks like kind of a lot, so we probably won't be able to finish it tonight. But this time tomorrow, we should be done with chapter 9. So, woo, woo, woo! Oh, do not disturb. Yep, let's throw that on. All right, do not disturb is on. We are locked in, Tim. Welcome back, Tim. Hey, Richard, welcome back. Awesome to hear from you. Let's go in early tonight. Yeah, welcome. I'm a little bit late. I'm about 45 minutes late than when I normally hop on, in around 7 p.m. Thank you for bearing with me. I was getting off work and grabbing some dinner and getting my dog out. I just gotta take care of my normal stuff before I can hop on. But I'm happy to be here and we're ready to learn. So right, we are on chapter 9, priority queues. Um, we are going to be, diving in here about bottom up heap construction, right? So bottom up. All right. I want to I want to what do you guys think about this idea? I want to kind of make the stream a little bit more fun, a little bit more interactive. And so I thought that maybe, maybe once a stream or maybe once every other stream or something, I think it would be kind of cool if we kind of took a break about halfway through. And I kind of wanted to, offer, a little bit something to give back to you guys for, staying in here and supporting me and joining me every day. Um, so I had this idea a little while back, and I wanted to shoot it by you guys again. I mentioned it a little while back, but let's go bring it up again. Is what if we opened up like once a stream or once every other stream, we opened up a Pokemon card pack, right? What if we opened up a Pokemon card pack live on stream, and then I collected the cards over the course of, let's say, a month or every 2 weeks or something, and then we pull a random viewer that submitted, and I'll put the cards into a little binder, and then I'll send it to you, and you can have the cards. How about that? I think that would be kind of a fun little Easter egg thing for the stream. You have to be here obviously to win the cards, which would be kind of you have to be here. So we would open it up like about halfway through, and then we would take a poll of who was here, and then they would go into a name, and at the end of the month we draw from it, and the winner would get the cards for those sessions or whatever. So we might do it like maybe every other stream or something. I'll have to see. I'm not trying to go broke buying Pokemon cards, but nonetheless. But I think it would be fun to also just do with you and then give back to you guys as a way to just say thank you. If you guys think that's fun, I just personally I like Pokemon. I grew up playing those games. I had the light blue, like the baby blue Game Boy Color. No, not Game Boy Color. Game Boy SP. Sorry, my bad. Is it Game Boy SP or Game Boy Advanced? I thought it was Game Boy SP. Hmm. It was the flip one. And I played the crap out of that Game Boy. I think I played that thing 12 hours. My screen, if I had screen time on that to track, I would have been over for me. And then I upgraded that. What I got for Christmas when I was a kid, I got the Legend of Zelda Special Edition Nintendo DS. So the gold one with the Triforce symbol on the front cover. So super stoked, but I think I still have all these devices in my closet locked away with all the old games and stuff. Um, but yeah, nonetheless that's beside the point. But I played those games religiously. I got an upgrade. I got the DSi after that, and then I got a Switch after that. I didn't buy the Nintendo 3DS. I actually, funny enough, I just found one randomly on the street. Poor guy, whoever lost it, feels so bad for you because he had Nintendo. No, he had Pokemon Black, the 3DS version, the upgraded one, and he had like everything. So poor guy, whoever lost his device, um, like poor guy, man. I felt bad, but major come up by me finding that 3DS. All right, gotta go to mall. I'll show myself. Ryan, you're doing it. That's funny. You got me there. Hey, Ja, welcome in. How's you doing? Welcome back. Tim, welcome back in like usual. It's awesome to hear from you. So lock in, welcome back in. Welcome. How's your project going? Are you and Script Serpent been building a game together? From what I hear, you'll have to throw a demo video in the Discord for everybody to check out or something. Hey, Script Serpent, there you are, right on cue. Hey, man, how's it going? On board with the Pokemon raffle? Yeah, I think that would be fun, right? We'll open up a pack or so every once in a while, and then I'll collect them, and then we'll give them away. I don't need the cards. It'd just be fun, and I can, show my way of saying thank you for, joining me and spending time here. So thank you guys, honestly. So I think that sounds like a great idea. Um, so I do want to do that. So I think that's what we're gonna do. Like 3 to 4 years ago, I replayed Pokemon Game Boy. It's one of the best old school games ever, man. Yeah, I played the. I can download an emulator just out of nowhere on my phone and just play the old Fire Red and Leaf Green just over again. Like they're just endless, timeless for sure. Hey Simon, welcome. Yoan, welcome. Awesome. Everybody's here tonight. If you guys are here to me, make sure to throw us a like on the stream. If you're enjoying your time here, we have a lot of regulars that are back in here. So it's awesome that we're here. So let's go ahead and jump into the reading for today. Well, there's Wingong. He's all good. Hello, Wingong. No worries. We just got started here. We're going to jump into some reading here. Then we'll break off into like a leet code problem or a neat code problem. Nothing too crazy. We'll probably just take a look at another easy one again today. Uh, Easy, quote unquote, and then we'll probably do some coding on the small business manager. I need to go through. We are getting to a point where we're starting to need to clean things up and start to kind of fix just some various bugs because the program really is doing what it should. We just now can just add more and more features or statistics for the actual business class or whatever. So that's what we'll probably do. But I need to go through so when you guys get it in your hands, when I push it up to GitHub, that you can read through the functions with doc strings and with comments and everything. So I'll have it really detailed for you, and I'll have a breakdown. All right, let's get reading here. So we left off on chapter 9, priority queues. We're going to drop into 380 bottom up heap construction. If we start with an initially empty heap n, okay, an empty heap, remember a heap is just a binary tree where you have ascending or descending heaps where either you get the root is the smallest number or the one with the lowest priority, so it is removed from the queue first, and we learned about various replacement methods for those that node, right? So if we start with an initially empty heap, n successive calls to the add operation will run in O n log n time in the worst case, right? However, if all n key value pairs need to be stored in the heap are given in advance, such as during the first phase of the heap sort algorithm, there is an alternative bottom-up construction method that runs in O of n time. Heap sort, however, still requires theta n log n time because of the second phase in which We repeatedly remove the remaining element with the smallest key. In this section, we describe the bottom-up heap construction and provide an implementation that can be used by the constructor of a heap-based priority queue. For simplicity of exposition, we describe this bottom-up heap construction as assuming the number of keys n is an integer such that n is equal to 2 to the power of h plus 1 minus 1. That is, the heap is a complete binary tree with every level being full, so the heap has a height equal to log n plus 1 minus 1. Viewed non-recursively, bottom-up heap construction consists of the following. Height plus 1 is equal to log n plus 1 steps. In the first step, see figure 9.5b. Okay, so this is what's happening here. We're giving a bottom-up construction. So you just kind of flat out provide all of the values on the same level. And then from there, how did you pull a 25? Oh, so then you loaded in more values? Okay, let's see what's happening here. In the first step, see figure 9.5b, we construct n plus 1 divided by 2 elementary heaps storing one entry each. Right here. Okay, right here. In the second step, see figures C through D, we form n plus 1 divided by 4 heaps, each storing 3 entries. By joining pairs of elementary heaps and adding a new entry, the new entry is placed at the root and may have to be swapped with every entry at a child to preserve the heap order property. In the third step, see figures E through F, we form n plus 1 over 8 heaps, each storing 7 entries. What is going on here? So we have an empty heap. We load in values to fill the first row. We load in values to fill the second row. We perform swaps, if applicable. We load in values to fill the depth equal 1. We perform swaps. And then we load the root and then bubble the root down. So bottom-up construction of a heap with 15 entries, A and B. We begin by constructing 1 entry heaps on the bottom level. We combine these heaps into 3 entry heaps. What does 3 entry heaps mean? We begin by constructing 1 entry heaps on the bottom level. 1 entry heaps on the bottom level. We combine these heaps into 3 entry heaps. What does 3 entry heaps mean? There's 4 values that are being loaded in. But before this was 1 entry. Why is this one 3 entry heaps? Oh, just like 3 like a subtree of 3, pretty much. And then we load 1, 2, 3, 4, 5, 6, 7. Okay, so it's talking about the subtree then. So then you go 7 entry heaps in this figure. And then we create the final heap with the root. Okay. Got some chats here. Ryan Trash says, gonna finish up the memory lecture one more time. BRB, no worries. Yeah, take a stab at that memory lecture. It was a good one. Definitely got a little bit tricky when getting into that pointer syntax for sure. Gonna need to take my time with the week 5 problem set when we take a stab at it tomorrow. So we'll have to be on the lookout for those pointers tomorrow. Sorry I missed your reply. We are making the game from scratch. I'm making the game engine. I am watching lots of videos learning the best approach. I'm close to making a full proof of concept. Nice. Let us keep us updated with how it goes. That's awesome. Okay. Python implementation of a bottom-up heap construction. Implementing a bottom-up heap construction is quite easy. Okay, for really. Given the existence of a down heap utility function. The merging of two equally sized heaps that are subtrees of a common position P, as described in the opening of this section, can be accomplished simply by downheaping position P's entry. The merging of two equally sized heaps that are subtrees of a common position P is, as described, can be accomplished simply by downheaping P's entry. For example, that is what happened to key 14 going from figure F to G. Oh, so you just, okay. With our array-based representation of a heap, if we initially store all n elements in arbitrary order within the array, we can implement the bottom-up heap construction process with a single loop that makes a call to _down heap from each position of the tree. As long as those calls are ordered starting with the deepest level and ending with the root of the tree, in fact, that loop can start with the deepest non-leaf, since there is no effect when down heap is called at a leaf position. In code fragment 9.6, we augment the original heap priority queue class from section 9.3.4 to provide support for the bottom-up construction of the initial collection. We introduce a non-public utility method, heapify, that calls down heap on each non-leaf position, beginning with the deepest and concluding with a call to the root of that tree. We have redesigned the constructor of the class to accept an optional parameter that can be any sequence of key value tuples. Rather than initializing self_data to an empty list, we use a list comprehension syntax to create an initial list of item composites based on the given contents. We declare an empty sequence as the default parameter value so that the default syntax heap priority queue continues to result in an empty priority queue. Okay, so we initialize with contents is equal to an empty tuple. Self.data is item key value for every key value in contents. Okay. Okay, so you load into contents, and then you pull from it key value pairs, and you make a item node out of every key value pair within contents and wrap it all within a list to make the tree. If the length of data is greater than 1, call heapify, which does what again? That calls down heap on each non-leaf position, beginning at the deepest and concluding with a call at the root of the tree. So start equals the parent of the length of self minus 1. Start at the parent of the last node. For j in range of start to -1 with a negative step. So we're going in reverse order. Revision to the heap. Interesting. Okay. Asymptotic analysis of bottom-up heap construction. Bottom-up heap construction is asymptotically faster than incrementally inserting n keys into an initially empty heap. Intuitively, we are performing a single down heap operation at each position in the tree rather than a single up heap operation from each. Since more nodes are closer to the bottom of the tree than the top, the sum of the downward path is linear, as shown in the following proposition. Prop 9.3. Bottom-up construction of a heap with n entries takes O of n time, assuming two keys can be compared in constant time. The primary cost of the construction is due to the down heap steps performed at each non-leaf position. Let pi of sub v denote the path from t to of t, denote the path of the tree from the non-leaf node v to its in order successor leaf. That is, the path that starts at v, goes to the right child of v, and then goes down leftward until it reaches a leaf. Although pi sub v is not necessarily the path followed by the down heaping bubbling step from v, the length of whatever that is, what does double bar mean? I know absolute value is single bar. What does double bar mean? Its number of edges is proportional to the height of the subtree rooted at v. Is anybody following this? What in the world? This is just getting really dense really fast here. We're starting to throw pi in here now. Like, I think it's just sort of to represent some sort of value, right? But we can bound the total running time of the bottom-up heap construction algorithm based on the sum of the size of the paths. The sum of v edges of the pi of v. Sum all the edges. For intuition, figure 9.6 illustrates the justification visually, marking each edge with a label of the non-leaf node v, whose path pi v contains the edge. What in the world? We claim that the paths pi sub v for all non-leaf v are edge disjoint, and thus the sum of the path's lengths is bounded by the number of total edges in the tree, hence O of n. To show this, we consider what we term right-leaning and left-leaning edges, those going from a parent to a right, respectively left child. A particular right-leaning edge E can only be a part of the path. What in the world? I'm going to throw this into the almighty orb. I need it to break this down for me. Please break this down in very simple terms. Let's break this down super simply. What's happening? We're trying to build a heap, a special kind of tree structure, from the bottom up. The claim is that the process takes O of n time, which is faster than it might seem at first glance. Why is this surprising? Normally, a single, quote, down heap operation, fixing a heap by pushing a node onto one node, can take O log n time because the tree height is about log n. Since there are n nodes, you might expect that building a heap would take O n log n time, but it's actually O of n. Why is it only O of n? It's all about how much work each node really requires. Most nodes are near the bottom of the tree and have short paths when you down heap them. Is this down heaping or is this is bottom up heap, not head, heap construction. Most nodes are near the bottom of the tree and have short paths when you down heap them. Only a few nodes are near the top and require more work, longer paths. Okay, so because you have more available, like in this tree, for example, right, this one here. In a normal operation, you would just load in from the root and then kind of bubble down the value. Or you would just append it to the end of the most recent place, or the most available rightmost spot, or in this case, if it's a new row entirely, the far left, most child of the leftmost leaf, right? So instead of just doing it one by kind of just loading in and then having it kind of plinko down, right, through this, it's kind of just like that's how I kind of imagine these numbers are kind of bubbling and plinkoing through, like bonk, 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 bonk. So instead of just one at a time or loading at the bottom and then bubbling up, you start empty. You start empty with and like base kind of you have to be full though, so you have to have enough data to be full. You load in the bottom, load in the bottom -1 or height -1, and then do swaps. Load in height -2, do swaps, load in the root, and then cascade it down from there. Okay. What's the path pi v part? For each non-leaf node v, so non-leaf node, so in this case 15, 5, 9, 7, 6, 17, 4, non-leaf node. Imagine that the path from that node to its in-order successor, the next node if you were visiting the nodes in order. So if I'm at 5, the in-order successor would be 6 here, or would it be 9, the lesser value on the subtree? In order successor. The path length tells us how long the down heap operation could take for that node. The sum of all these path lengths is the total cost of the building of the heap. Why is the sum of all the path lengths O of n? Right-leaning edges. Edges going to a right child can only be part of one path, pi of v for one node. Left-leaning edges. Edges going to a left child can be part of only one path leading to each unique leaf. Since no two paths share the same edge, the sum of all path lengths is equal to the total number of edges in the tree, which is O of n. What? The total work of the bottom-up heap construction is proportional to the number of edges in the tree, which is O of n. Oh, because you only have to do as much work as just filling spots, basically. Is the in order successor the node next in the array, so the sibling, or is it the child? An in-order successor is not necessarily a sibling or a direct child. Instead, it's the next node in an in-order traversal, visiting nodes in left, current, right order. Here's how to think about it. If a node has a right child, the in-order successor is the leftmost node in that right child subtree. If a node doesn't have a right child, if a node has a right child, the in order is the leftmost node. Okay, so you would traverse here in order, right? You would show me an example, please. What's it gonna generate me here? Oh my gosh, what is that? What is that? In order successor. Get out of here. Just use a no. Left, root, right. So let's talk about in order traversal again. It's the left, current, right. Go to A, B, A. So I have my notes up here for the in order traversal for chapter 8. So here we go. Pre-order, post-order, breadth first, in order traversal. So you would go all the way to the leftmost child, go B to E, travel up to the root, then go C to F. Okay, so you kind of interesting. Okay. Yeah, Jevin K7. The link to the PDF is just in my Discord link below, completely for free. I have just a uh, jumble of all my resources that you see me using on the stream in the Discord below. From CS50X to all the books I read, to my notes, to my projects, everything is in there. Okay, let's keep going. Almost done with this. One more page here. Then we're done with this section. Python standard distribution includes a heapq module that provides support for heap-based priority queues. That module does not provide any priority queue class. Instead, it provides functions that allow a standard Python list to be managed as a heap. Its model is essentially the same as our own, with n elements stored in a list cells L0 through Ln-1, based on the level numbering indices with the smallest element at the root in L0. We note that the heap queue does not separately manage associated values. Elements serve as their own keys. Yeah. The heapq module supports the following functions, of all of which presume that existing list L satisfies the heap order property prior to the call. Heap push onto list element E, push element E onto the list L and restore the heap order property. Executes in log n. Heap pop, pop and return element with the smallest value from list L and reestablish the heap order property. The operation executes in O of log n time. Pop and return the element with the smallest value. Okay. Heap push pop, push element E onto L and then pop and return the smallest item. Slightly more efficient than separate calls to push and pop because the size of the list never changes. If the newly pushed element becomes the smallest, it immediately returned. Otherwise, the new element takes the place of the popped element at the root and the down heap is performed. Got you. Heap replace, similar to heap push pop, but equivalent to the popping performed before the push. In other words, the new element cannot be returned as the smallest. Again, the time is O log n, but it's more efficient than two separate operations. Heap replace, similar to push pop, but equivalent to the popping before the push. In other words, the new element cannot be returned as the smallest. The module supports additional functions that operate on sequences that do not previously satisfy the heap order property. Heapify L, transform unordered list to satisfy the heap order property. This executes in O(n) time using the bottom-up reconstruction of an algorithm. Bottom-up construction algorithm. N largest takes in k and an iterable. Produce a list of the k largest values from the given iterable. This can be implemented to run in n plus k log n time, where we use n to denote the length of the iterable. And then n smallest k iterable produce the list of the k smallest values given it an iterable. So it'll give me the 5 smallest values of this. Okay. Cool. Richard, so this is starting in order So is this starting in order from root to 16, bottom left node, then somehow counting from each edge left to right? So you're talking about this example up here? Where'd that go? Here? So the starting in order, you go 16 to 15 to 25 to 5 to 9 to 14. No, sorry. You go 16 to 15 to 20. No, how do you do it? So this starting in root to 16, bottom left, and then somehow counting from each edge left to right. The edge is leaf to root. So you go 16 to 25 to 15 16 to 15 to 25 to 15 to 5 to 9 to 14 to 9 to 12 to 9 to 5 to 4 to 6 to 7 to 11 to 7 to 8 to 7 to 6 to 17 to 23 to 17 to 20, and then all the way back to the root. Is that how it works? That was a mouthful. All right. Cool. We'll stop there for today on section 9.4. So I got to come in and take some notes here. I'll come back offline and do some better notes here for this. But that will be it for that one here. Let's go ahead and take a stab at maybe a Neet code problem. What do you guys think? Anybody down for that? Root to 16 to 25. Okay, so you said, where'd it go? Keep passing it. Root to 16 to 25 to 14 I'll have to look up some videos or something. Alright, let's see here. Let's see here. Should we do this one? Hold on, let's see. You're given a room. Hold on 1 second. What does inverting mean? Oh, mirroring? Huh. Well, because we're talking about trees here, we should try this one. Should we try the invert binary tree problem? Because we're talking about this kind of stuff. So, given a... So this, you're given a definition for a binary tree node. Class tree node. Initialization of self, value, left, and right. Value, left, right. Invert binary tree. Self. Invert tree. Self. Root. Optional tree node. given a root optional tree node. Okay, should we try this one? Or should we do a different one? What are some other options here? Should we pick and choose? Maximum depth. I mean, all these ones are good practice for this reading that we're doing. Given the root of a binary tree, return its depth. The depth of a tree is defined as the number of nodes along the longest path down from the furthest leaf of the node. So 0, 1, 2, 0, 1, that would be the longest path, the highest depth. So the thing is, though, is how do you go over like when dealing with an array of binary, like a binary tree array, how do you like handle the loop? That's what I don't really get. Like that's what they didn't explain is when while you're looping is how do you know that you're on. Well, if you go to 1, 1 has 2 children. 2 has 2 children. 3 has 2 children. So that's what I don't understand is how do you do the looping over a tree array? So that's trees. Heap priority queues, we're talking about that. Okay, so maybe we should just in recursive DFS, you count for base case, run left side with a variable, run right side with a variable, and return with problem logic. Yeah, I'll have to look up more stuff on that. That does not seem like I'm there yet. Okay. Product of an array except self. Given an integer array of numbers, return an array output where output index I is the product of all elements of numbers except numbers index I. Each product is guaranteed to fit a 32-bit integer. Okay, so this problem is saying that you have an array of numbers. You have to use an array of numbers. Given an array of numbers, you output a value, which is the product of all the other values except for the index that you're currently on in numbers. So 2 times 4 is 8, times 6 is 48. 1 times 4 is 4, times 6 is 24. 1 times 2 is 2, times 6 is 12. 1 times 2 times 4 is 8. Okay. Uh-oh. Not this again. So let's think here. So could you solve it in O of n time without using the division operator? Okay, so let's just think here. So, well, what's the product of all of these numbers together? Okay, let's just start there. So 1 times 2 is 2, times 4 is 8, times 2 times 6 is 48. Okay, so you get the 48 just because the first index happens to be 1, right? So it's kind of a little bit of an edge case thing, but it's whatever. So if the whole problem is 48, let's say that we're on index 1 of 2, well, 48 divided by the index that you're currently on is 24. Okay, let's say you're at 48 and you're on the index of 2, so the 4. 48 divided by 4 is 12. Okay, so I can see how you could do it with the division operator here, but do it without the division operator. Solve it in O of n, so a single pass through numbers. Okay, so let's just think here. Let's grab the whiteboard. Let's think here. So if we have an array with a value of 1, 2, 4, and 6, right? And we're looping through this array one single time, O of n. So if let's just say that we're on this first value here, right? Highlighted in red here. We're on 1, okay? Index 0. Well, what do we know right off the bat? Well, so we'd obviously have to do some sort of loop, like for I in range length of, right, nums, right? We're on nums index I here, which is right here. Well, right off the bat, we know this. We know the length of the numbers. So can we not just look at the first value, predetermine a maximum product dependent only on that value? Meaning like, okay, so if we're on here, we take the length of the array, which is 4, right? Okay, so the max product of this array is this value 1 with, like, if we were theoretically, if we're blind to all the other values to the right here because we're iterating over this in one single pass. So we're only seeing this and we only know the length of the array that we're on, so we haven't gotten to the next value yet. O of n Right, so if we're blind here, so then what if we start from the back, Richard? Right, so what if we start from the back? What if instead, so is this array always in order of least to greatest? It looks like it. At least the examples they gave us are ordered. So what if we start from the back then? Right? And say we're at -1 here, right? If we're on the back. So if we say, okay, we're at a value here, which is technically our largest value. So the max product that we could technically get is if we see this value 4 more times, 3 more times. So it technically would be 3, or it'd be, nums index 1 and nums index -1 to the power of the length of numbers, right? That would predetermine 6 times 6 times 6 times 6. Now, we're not getting spooky here with that, but that would give you technically, if you were to see this max value more time, every single time from here on out, if you're blind from here on forward, right? This is your blind. You cannot see. I'll make a little eye here. You cannot see. You would have 6 to the power of what? 3? Length of numbers -1, actually. 6 times 6 times 6 times 6. Right, where's my cell phone? Here's the math here. Yeah, right. So think here. So if you're at 6 times 6, 6, so 4. The max product that you can have is 1,926, or sorry, 1,296. So if we had 6, 4 6s in a row, 1,296. Now, what if we do that again, but for all of the next one? So we have all 4s now, but we do it for every single numbers index 1. Numbers index next times 2. Hey, Zanab, welcome. So let's just say on this first pass, right, you get, if this is your original array here, and we start at the back, we say, okay, you get 6 for everything, okay? Because you're starting on this value. Then in the next iteration through, right? You're on this value. You detect it's a 4. So do you do 4 times 4 times 4 times 6? Because you knew that was a 6. So this gives you 1, 2, 9, 6. 4 times 4 times 4 times 6 gives you 384. Okay, in the next pass through the array, or not pass, but the next loop, like next movement, we find that we're at 2, so that we get 2, 2, 4, 6. 2 times 2 times 4 times 6 equals 96. And then we get 1 times 2 times 4 times 6, which is equal to 48, right? So what do these numbers then tell us? 12,960 minus 384 minus 96 minus 48, 786. That doesn't really tell us much. Oh, and Woo, I would really appreciate it if you would stop spoiling solutions. I would hate to have to time you out, my friend. We're trying to really work through these and trying to understand stuff. This really does no help if you just, spoil things in chat for everybody. All right. So that doesn't really tell us much. I mean, what if it's not supposed to divide, but gives you a really small number. It's an interesting concept, but I don't think it's right. Yeah, Richard, I was following you here. 6 times 4 is 24 times 2. Okay, so that was not the way. Not the way. So should we try to solve it with the division first? We're working on the products of an array except self first. So we identified that you can take the product and then just divide out the current value you're on and then return that array backwards, right? So that would take, O of n squared to pass through and then build the second array. How can we build the second array live? So if we have 2 pointers, one times 6, 4, 8. So what if you go forward? What if you go front to back and enclose in and compute the product that way? No, because then you have to. So if I'm at -1, how do I get up to 4? Add. Hmm. I'm on the board with trying to solve however you see fit. I'm momentarily lost, but trying. Oh, 2 pointers could be good. That 0 is going to be something we have to watch out for. Can't lie. That 0. I was thinking num's index 4, but in reality, the index would be 3, so my initial starting place was wrong to begin with. So what are we thinking, Richard? So are you trying to go from the back like we were before and filling in all the values? So if you have 2 pointers, so if you have 1, 2, 4, 6, right? If we're on, if we have our pointer I is here, and our pointer J is here, one forward, it's I plus 1. If we're here, okay, here, hold on. So if we're here and we compute J forward, we already know what the product is of 2 times 4 times 6. That can be saved, right? And so that would be 24, 48 right off the jump. That would have, no, that would just cause you have to do, that would be n minus 1. O of n minus 1, because you would do that, and then you could just, I mean, for the other solution I was thinking of, right, the one where we can just do the division. I know it says, can you think of it without division? What if we just said, output is equal to nums copy I'm gonna say for I, or no, so the length of nums for I in range of n. Right, we need to compute the product here. So what if we computed a midpoint, had 2 pointers work inward to the middle? We could say while I does not equal middle plus 1 and while j does not equal middle, right, that will loop I and j inward towards each other, computing the product. I mean, is that any different than just doing a single pass through and computing, right? So you could just say like prod is equal to what, 1 for I in range prod nums index I output index I equal to prod. So product. Oh, hold up. I didn't know. Hold up. So we're saying starting a product new one. So at 1. So 1 times 1 would be 1 in the products. Times 2 times 4. We'll gather the entire product. So if I just take these two arrays together, I have a copy of my original one. I gather my product. I then say, for either range length and numbers, so this will still be the same as output. So what does the product tell me? So this would be 1 times 1. I can multiply this value by output index. Nums -1 times nums previous index times 2. Could it fit your route? N minus equals 1? What? You want me to reduce the range each time? So if I reduce the range each time, so I go, that'll stop on the last value. That won't, okay, so if I reduce the range each time by 1, it'll just, so it'll be here for all of it. Reduce down to 1. Let me zoom in for you guys. Reduce down, so if we're, okay, so if we have the product, right? Okay, let me say, for j in range n, right, we have the product, which is 48 in this case. We do output temp is equal to output index j. So we save output index j. So we save the 1. We plug in product into there. Output index j is equal to product. And then we do the division divided by temp here. So what this will do is I generated my product, 48. I insert my product at each spot in my output, and then I divide it by what was currently in that duplicated list. So I'll insert 48 into this first place, divide it by 1 to remain with 48 there. I'll insert 48 divided by 2 to get there, insert 48 divided by 4 to get there, insert 48 divided by there. So for the second case, I get the product of -1 times 0. So the product is just 0 for this entire thing. Oh, shoot. Oh, shoot. No. So in here then we'll have to have a catch for if temp is equal to 0. Oh no. So if the 0, if I on this initial pass is going to make my product, total product of this array 0. So if I try to insert 0 into the basically the dummy array, the output copy, the input copy from my output, it'll insert 0 into all those places and then try to divide by my value, my initial numbers. Oh. Yeah, so this would be O of 2n, right, Priyanka? Right, because it's not nested here. So it's not terrible, but it's not O of n. I mean, it's O of 2n, so if you get rid of the constant, it's O of n. But we are using division here. Ah, crap. Nums index j, not output. My output is my copy of my nums, so it's fine as long as I save the temp before I override the value. Oh, crap. Stop. No, yeah. So what happens then if it... So then in that case, so if our product of value is out to 0 in this case, we would have to go, we would say, okay, 0 or 0 divided by -1 is 0. 0 okay, so shoot. So what if I go prod how can I say this? How can I say like zeros 0 present is equal to false if 0 present equals to true. Set prod 0, 0. So let's say prod 0 equal to 1 here. So we'll have to do this in the loop though, right? If n index I is equal to 0, 0 present, or we don't even need to do this catch here actually. We'll just say, we'll set prod 0 is equal to 0 here. We'll override the value, right? We'll continually gain, increase prod, we want to pass over it if it's 0 and gain a total prod no 0. I guess we could say else do this no pass, like that. So we'll skip over the 0. We will, if we get a 0, we will indicate that we have a 0 by setting this to 0. Then we need to do a check here and say, so our product will gather the entire product of our non-zeros. So we'll say if in this loop down here, right? If n is equal to 0, so then we need to say that if we detect that if temp is equal to 0, right? If temp is equal to 0, meaning that we're in this case, we need to just insert at that place the product of the non-zeros. So this is, wait, hold on. If temp is equal to 0, meaning that we're at this part, then we need to set output index j is equal to prod no zeros. Else output prod divided by temp. If not your edge case, if not 0. Times 2. Okay, so we can't see what, oh my, sorry. How can I, there we go. Right, so what's going on here? Okay, so I'm looping over my initial input, nums. Okay? If n at index I, sorry, not n at index I, nums index I is equal to 0, our prod 0 will be overridden with a 0 value. Else, our prod no 0 will be increased by the product, right? Okay, so that will give us two things. The product of the array without including any zeros, if there are two zeros in the list, well, that it'll still meet this condition, right? Because it happens for every index of numbers, right? So it'll still evaluate to this if statement here. And it still would just be set to 0, so it's fine. And the else won't be kicked in. It'll just pass to the next loop. So then we have a product of all of the not including zeros. So that would give us that -6 we're looking for in this second case. And it would give us, in this first case, just 48, right? We then say, we loop again using just j this time, just for clarity's sake. We save the current value of output, which is just a copy of the numbers, right? So we save the 1 as temp. If temp is equal to 0, we set output at index j, right? This current, right, or output, right, which is just a copy of this one technically. We set it to the prod non-zero if it's equal to 0. So here, if it's equal to 0, we set it to the -6. Else, it's not equal to 0, so we set the value here in the output to the product oh shoot. Because we have that. Oh, shoot. So we have to put in else the current value we're on is a -1. If the product, the overall product is 0 though. Else if prod 0 equals to 0, right? We're going to do output index j is equal to prod is equal to just 0 divided by, or prod 0, just to be consistent, divided by temp, right? Else prod no 0 with temp. So where my -6 is coming from. So in this output here, so I'm looping over my array numbers. Maybe I have it wrong. This is just my first idea pass about this. So I'm just trying stuff. Um, so I loop over the array of numbers. If numbers index I equals 0, I set prod 0 equal to 0 rather than 1, right? Kind of like a switch. Hmm. Prod 0. So I'm looping over. I don't think I had this right, but it was a good idea. It was a fun approach. I loop over. If I am on a 0 value, I set the prod 0 equal to 0. Else, I gather the products of all the non-zeros. So that's where the -6 would come from. Is at the end of this initial loop, for this case, prod 0 would be 0, and prod non-zero would be -6. I loop over again, this time kind of evaluating my output this time. If the value that we're currently on is equal to 0, we set the current index of output we're on equal to the product of non-zero, which would be -6. So if we're on 0 here, we would set output index 1 to -6. Else, if prod 0 equals to 0, output index j would equal prod 0 divided by temp. Temp would never be 0 here because it would never meet here, because if temp was 0, it would be evaluated to here. So we would never divide by 0. Is that not? Magnet says, I have an idea. What if we store two values, mid product and edge products? Okay. Go on. So, I'm just curious. Yeah, Magnet, go for it. You definitely should give it a try. If you definitely, even if I'm not even getting it here, I'm just hitting dead ends. But by going down this process of hitting dead end, hitting dead end, hitting dead end, I'm learning from these approaches, and I'm just practicing my iteration. I'm practicing my walking through this, visualizing it in my head. So it's just more and more practice. So I don't mind if I'm not getting this, right off the bat. It's okay. I'm not in any rush here. I think people often get, they feel like they're in a rush to get these done, and I'm not in any rush. Okay, so let me take this here, go into here, bring this in, there, there, there. So then give me this. All right, let's see what happens here. Probably don't have it here, but let's just see what happens. 48, 24, 12, 8. Yo, that worked for the first case. It gave me floats, but that worked. Not too bad for the first case. Now the second case? Oh boy. Why did he give me floats? Anybody know? Why did this give me floats? Yo, I got it! I did it! I'm doing integer diversion instead of floor. Well, Python doesn't have double like this. It should just be. Oh, yeah. I did it! Woo! Oh! At least for these two cases. Yo, no way! Let's go! Woo! We get a celebratory Sky. We get a celebratory puppy feature for that one. She does not like it when she comes over here, but she's. Hey, you're okay. You stay. We did it. Well, we got to submit it, but let's see. We might have some edge cases or something for some specific things, but for these two conditions, we passed. Okay. Oh yeah, sorry, I keep getting confused with my C and back in Python. C does the floor division with that, but Python you have to do two to get the floor. All right, let's see here. Do I return? Run. Okay, I passed that. Submit. No. All right, so for 0, 0, I gave a 1, 1. So for a 0, 0, I gave a 1, 1. Where'd you go? Let's do that. 1, 1. Why did I give a 1, 1? Hey, JP2417, thanks so much for your question here. Hey, Michael, I finished part 1 of Python Crash Course. You recommend starting Neet/Neet code. Honestly, if you just finished Python Crash Course part 1, I would say no. Now, you can definitely try. There's nothing against you from trying, and if you want to try, definitely go for it. But I really think that you should try, if you haven't yet, to make some project, get some actual practice with, iterating over data, your own data. It really, really helps to kind of, understand it, because right now you're given just some basic tools, and now you need to start building stuff with them to get some practice with these kind of algorithms and stuff. Now, I'm not even that great at this stuff, and I'm really not good at all in terms of I struggle with all this stuff. So I I yeah, that's just my advice. Is this stuff does get pretty hard, and so I mean I struggle too with it. So if you just finished Python Crash Course, I recommend building some projects, maybe starting CS50X or P, um, and doing a little bit more practice, and maybe trying a couple easy ones. Taking a stab at it won't hurt, but yeah, there definitely might be difficult. Okay, so why did we get 1 1 here? If numbers is 0 0, we go. So what happens if I print prod no 0 here and print prod 0? Prod no 0 is 1. Oh, okay. Right, because it's passing over the zeros. Else, okay. So if they're all zeros, then can we not start from 1? Mm. So if it's all zeros, right? That's what's happening. If it's all zeros, it's starting with 1, not accessing this value. Right? Not even doing this, so it's leaving this as 1. So if I had this start at 0, if I have this start at 0, if prod no 0 equal to 0, prod no 0 equals to 1, and then call this. Okay, now I get the 0 0 back. Perfect. That fixed that edge case. So let me bring this back into here. Loading up. Bring this down. Bring this over into here. Where was it? I set prod no 0 equal to 0 at first, and then I made an else if statement inside here saying prod no 0 equals to 0, prod no 0 equals to 1, like that. But let's make sure that that actually works with our other cases. Or do we just break stuff? Let's find out. $48, 24, 8. Okay, let's try this other one. shoot. No, we're breaking stuff left and right here. Dang. Shoot. Shoot, shoot, shoot. So now we're missing this part. So we're not getting this second case now. We're getting inversion. So if prod 0, if temp equals to 0, output index j equals prod 0 minus 1. If temp is equal to 0. So prod no 0 is negative 6. After sign into Neet code, how can I access this course? You just go to the roadmap. The roadmap, and then it goes like in order. What's nice is that what I didn't realize at first is I was kind of doing problems pretty scattered, and that's why I was struggling. But what people and the subscribers and you guys have suggested to me is that I do the Neet code 150, which he has tailored to be in a specific order that you go down and learn from there. That way, each problem is like one level, one like little like elo tick higher than yours, than your current level, so that you can like continually just have like that carrot at the end of a stick, and you're constantly just projecting forward basically. um yeah, it's in the roadmap. Okay, so now we're failing this case where prod no 0 is equal to negative 6, perfect, and prod 0 is equal to 0 because we have zeros in this case, great. If temp is equal to a 0, if temp is equal to a 0, which is our current value, so it's not in this case, else if prod 0 equals to 0, if prod 0 equals to 0, which in this case it does, we're going to set output index j, so the negative 1's place is equal to prod 0, 0 divided by temp. Okay, I think we need to use, how can we use the debugger here? Okay. Okay, so step into j equals 0, I equals 4, n equals 5. Output currently is this. Okay. Temp is equal to 0. Output equals 0, negative 6, 0, 0, 0. Oh, hold on. How do I go back? Restart. So if I step into this, temp becomes 0. Prod still -6 and 0. Why did it override the value here? You copy the output, so the output is wrong? My indentation is incorrect? The nums. Yeah, I copied the nums strategically so I can do this division on my output evaluation. But what's going on here now is I'm getting, in my 0 cases, I'm overriding I'm overriding the inverse. It should be 0, -6, 0, 0, 0. So I broke something here. It's happening here from that debugging though. So if temp is equal to 0, which in this case it is, output j is equal to prod non-zero, which is oh wait. Oh, I'm stupid. Hold on. This is the what I'm supposed to be putting in. What am I doing? There. Okay, so it still works. I'm just being dumb. I just had the wrong input in there. Oh, I'm so dumb sometimes, guys. I'm so dumb sometimes. So let's make sure it works for this guy. All right, let's run that. That works too. Perfect. Okay. So let's see. This one run. All right, let's try it again here. All right. Ah, dang it. 080 is another edge case. So we're starting to realize that our code is pretty faulty here. We got a lot of edge cases. 080. We should be getting back. What do we should be getting back? 000. What? Not including this one. I should be getting 64 here, no? 080? Oh, so if I'm here, not 0. If I'm here, 0. Okay, so I should be getting 0 all the way through. Okay, great. Oh, shoot. So now we got to deal with this. 080 should be getting triple zeros. Oh boy. Look at nums at top of your code to output instead of nums. What? Hold on. Copy the expected output. You copy the expected output instead of input from the question. Oh, you're talking about that up there, yeah, from before. I thought you were referring to this copying. So, right, our prod of non-zeros is 8. Our prod of zeros is 0 because we do have a 0. So we're saving, 0 gets saved here first. Yeah, I had the wrong list copied in here at first. That's why it was giving me those problems. So, thank you guys. I appreciate you. So if we have so temp is going to be 0 saved here for 080. If temp is equal to 0, we're saving 8 here. So this is where we have problems, and I think we're broke here. Right, because I'm saving 8 here. Because we have this edge case of a length of 3 with sandwiched zeros on either side. Oh, shoot. Thank you guys for joining me here. Quick introduction. My name is Michael. I'm 26 years old. I graduated college in 2021 with a degree in human biology and a minor in chemistry. I work as a chemist for a biotech company where I make biological controls used in diagnostics in both the clinical and research settings. And it's used to diagnose patients for what they're supposed to be used for. I guess I don't know. So I've been doing that since I graduated college 3 years, and so 3 years ago, and I've been teaching myself Python and programming for about 6 months now, and it's been quite the 6 months. We've been doing it every day for about 2.5 months, but before that we were doing it part time, but we were really really grinding here. Hey Tigreo, welcome. The code is fine, you say. Okay. Well, obviously not, because we failed. So, do you have any input or suggestions? So we failed the 080 case. Should have gotten all zeros. Right. I mean, I could try to do two nested for loops and just brute force the value every single time, but I was trying to just do it, compute the value once, not have to do the math again, and then just kind of do some fancy or just some iteration, and then kind of swapping and doing some of that. Want to write a compiler? We're learning C right now, so maybe if we get after we finish CS50X and start getting to some projects, maybe we can dive down into that for our final project in CS50X or something. We'll definitely need some practice in that area to understand that stuff. We're doing the Mahan. We're doing the um, product of array except self. I've My code passes the runs for the two test cases, but I fail some specific edge cases now. So I know where it's failing. It's failing right here, but I don't know how to fix this part now. right? Because if the temp is 0, in my other case, right, in this case here, my temp was 0, so I just saved it as this one. So what if I have a 0 count? Like if I have more than one 0 in the original numbers array, what happens? So if I'm here, you get 0. If I'm here, so if you have more than one 0 in the numbers array, you have 0 all the time. So we do need a 0 counter, actually. So if prod if equals 0, 0 count plus equal 1, we'll have 0 count equals 0. So then here we'll say if 0 count greater than 0 or greater than 1, output j is equal to 0, else output j is equal to non-prod, like that. So let's try this. Let me try to put this into here really quick. So I gave myself a 0 count. I also, within my here, I counted up 1. And then I said, if 0 count greater than 1, output j is equal to 0, like that. So let's see what happens here. Ready, guys? Let's see. Show me the money. We're looking for 0, 0, 0. Oh. No! So if numbers equals to 0, prod 0 sets to 0, 0 count gets increased by 1, so let me print 0 count here, see what that's at. 2, okay. Temp is equal to 0. If 0 count is greater than 1, output index j is equal to 0. Oh, else output, there we go. Boom. Okay. Yeah, we did that there. Okay, now let's run. Pass. Yes! Woo! Let's go, boys. Awesome. Doom. We got that in O of n. O of 2n, really, but O of n if we get rid of the constant out front. Not bad, not bad. Yes, I feel that was awesome. You know, that took us, a good hour to solve, but the thought process that we went through, we didn't use any AI, we didn't look anything up. We just plugged and chugged and debugged using print statements, using the debugger. I rarely use the debugger, so I forced myself to use it this time around. I, tried various different inputs. I feel that was awesome. I feel really good about that one. Beast, man. Awesome. Thank you, guys. Did you solve that one, Richard? You probably got it. You're a beast. Woo! Let's go. It really helps you guys. I'm preaching to the choir here, but honestly, going loop by loop, printing out what was happening at each loop, understanding it. I need to utilize those printing and debugging skills more often because when I did it here, it really helped. Oh, Richard, you got it. You got it for sure, Richard. You had some good thought processes on that multiplying. There's definitely a way to do it with two pointers, as Owen was suggesting above. Let's see what he was suggesting. I kind of scolded him a little bit because I didn't want him to give it away. He gave an approach, but out of spite, I didn't want to go down his approach because he kind of spoiled it, and I wanted to try it, individualistic way or my way, because I was already going down this path, but I I appreciate though the help, and he says so. Owen says total product divided by current element. Okay, that was the division part. Prefix and postfix products is the only way. Accumulate forward and then backward. Accumulate forward, then backward. Oh, so you accumulate the product. Okay, so let's see here. If my array is 1, 2, 4, 6, and I'm on this value, I compute the product forward. If I'm on this value, I compute the product in the back and forward. But I feel like that does like repetitive work, no? Because you already solved. I guess if you can't use division though in his little thing. So would you just slice gaining the product forward and back? I feel like that uses a lot of more. You take a slice at each iteration, forward and backwards, excluding the current value you're on, computing product, and then summing those two together, and then putting that in your output space. Um, what is the strategy used here? What should I study and practice to be able to do what you did here? I watched you from the start to finish and was really impressive. Thank you, Richard. I really, really appreciate your positive and kind remarks. You're really awesome. Thank you so much. You know, I often have this kind of like imposter syndrome. I really don't feel like in that intermediate realm. I really honestly feel still in that beginner area where I still feel like I'm trying to figure this stuff out. And I think it's just because like I've been doing it every single day. So it's like been just compounding. I haven't really caught up with it and just in terms of maybe how much I do technically know at this stage. But I would just say what has really, really, really helped is just the sheer amount of low level practice um, that I put in. Like, even though I already took CS50P and I already learned about arrays and dictionaries and functions and whatnot, I still spent many, many hours reading and going over all of the in-text practice problems in Python Crash Course. I already was familiar with what was talked about in CS50P, and yeah, I could have just moved on and just started learning JavaScript or learning C or learning web dev or something, but I didn't. Instead, I said, okay, I learned that, but do I really know how to use loops? Do I really know how to index? Do I really know what it truly is and what's going on? No, not really. And can I solve these kinds of problems with that information? No. So I just said I need more practice. So I said I I just really grinded through just basic problems. The Python Crash Course has the in-text try it yourself practice problems that break things down into dog, cat, pizza, like just simple kind of elementary examples. But they're really, really good in nature because they just have you actually do it, and they talk you through it step by step. And now, yes, David's good about doing that, but in the CS50, but he has to fit it all in a certain amount of time. When you have a physical book in your hand, the page does not turn until you turn it. So why turn the page and move on when you don't understand that truly just doesn't make sense to me. So I really try my best to absorb everything that's on the page and really take it in and get practice with the examples before moving on. And this and setting myself up with that beginner knowledge really, really helped, because when I got into these leak code problems, if I was trying to solve the leak code problem but then also remember how to actually iterate, remember how to index, like I would just be shooting myself in the foot. I wouldn't be able to use all of my brain power, problem solving, thinking of different angles to attack this from, like whether going in the back or the front or two pointers, or using just two loops, whether in nested or just in parallel. Like it, I and so if I was thinking about the syntax and how to actually write Python, I would be lacking in my ability to problem solve. So I didn't want to be thinking, have like an arm behind my back trying to, keep up with the syntax while also trying to solve hard problems. I wanted to be fluent-ish already while solving these problems. So that alone, I guess, is a huge, huge factor. And then, like Ryan says, not being able to work on it every day is a big thing too. Um, I often give this analogy, but at the very start, it seems very linear for the learning, or it seems quite exponential because you're just absorbing so much at the start because you just don't know anything. You're just taking in print statement, functions, loops, boom, everything is new. So you're just right off the jump, you're just boom, take off. But then at a certain point, once you learn that, it starts to plateau, and then it sort of stays linear with the amount of time you put in. But then if you're really not trying with that amount of time, you're not engaging in the material, like I am doing this stream, I'm talking with you guys, working through these problems, reading the text, editing my videos, rewatching the streams, talking with you guys on the Discord, making Discord posts. All of that is just using, reconveying these coding concepts over and over and over again. So I have the least likelihood of being able to forget it. So that also comes into play with that syntax I was saying, is because I've been practicing the syntax every single day, as I'm not going back and having to say, okay, how do I actually have to, how can I access an index, or how can I, it's just kind of, it's just there. Like my fingers just do it. Like it's just by typing. Now I do have a long ways to go. Like this is not at all a like end of the race. Like still a novice. I'm very new at this. I've been only doing it 6 months. I do not have a CS degree. I am a physical scientist. I'm a chemist, a biologist. I do so. This is just out of sheer willpower and just willingness to learn and drive, I guess. But I tried my best to convey like that beginner point of view through this stream because no one was really showing what it was like to struggle. And I wanted to see the struggle between me like really having to think about this, and yeah, I might look dumb, or you guys might know it before me and solve it, and then I'm you guys know I don't know it yet, whatever. But at the end of the day, like that does not matter. What matters is if I learn the material. Like that's what truly matters, or if you learn the material. So, and how well you know it, right? Um, um, Mahan says, yeah, he is right. I'll also read mine. Maybe you could understand reading from two people. I said the same approach. Oh, you did, Mahan? Sorry, I didn't see that. But I would do what I would do is do lists, one product of the left and one product of the right, and then figure out how to get the product without I. I mean, from index 0. Okay, so Mahan, you're basically were saying to have basically slice excluding the current value of I that you're on and just concatenate those lists together, those product values. Um, yeah, Mahan, I should have a little bit of time. I'm probably gonna keep streaming though for a little while here. It's a Friday night. We're feeling good. Sheer amount of low level practice. Okay, I have been coming to this as an idea and hearing this is just really enforcing this is just a must do. You lost me with zero, non zero, the J loop, and the temp. Yeah, honestly, that's what I'm saying is if I was having to think about the iteration process rather than actually solving the problem, I would just be handicapped at trying to actually solve the problem. So, but really, what's going on here with this J loop is no different. I'm just using J as just a different variable than but this is a completely different scope than I. So I could have actually just overrode I and used I here because I never call it again down here, right? Or so I could have used I and just replaced I continually in here, but I just chose to use J just to syntaxally and visually break it up. But these are completely different scopes, so I could have used I in this case perfectly fine throughout this entire loop. Because right, I breaks the variable I no longer has any use after this loop. Now I will still be in memory technically the value of the last um, whatever the length of the numbers, right? So it'll be um, exclusive, so it'll be the last index, so the length n minus 1. But if I override I here in this scope, then I can just be whatever I want it to be. But if I were to say print I down here, you would see that I still is that n minus 1 because it's saved in memory internally, somewhere. And but I can override it in this scope and use it again. I'm just doing this same loop again, but instead of looping over and evaluating the numbers list, right? I copied the numbers list into an output list, and then I just, because I knew that the 48 was just the divided by 1 is 48. So I just pretty much stuck that number into the output, but I had to use a temporary variable so I could save it, right? So I saved the output value first, so then I could overwrite it, and then because I needed to maintain that temporary value later on down here. If I had just overrode output up here, right, and or in this case, I couldn't call output J right here because it's being overridden in this case. So I couldn't do that, or maybe I could. I'm not sure. Output J. Can you set a value on itself, on an operation on itself? Maybe I could have, but I just decided to use a temporary variable here. Um, if you follow along with my Harvard CS50X course, David did a really good job of breaking down the temporary variable when we were doing the sorting algorithms and how you needed to save the temporary variable for doing like the swapping of positions. So I highly suggest maybe taking a look at, I think that was week 3 in CS50X for Richard, if you're wanting some more practice with iteration and things like that, CS50X is a great way to do that. It really helped. It's helping me to understand iteration on that lower level, seeing what's going on with these variables within memory, within pointers, with the for loop. You can't use range, right, like you can in Python. So you're forced to use for I in some sort of range up to n. Like you can't directly call range. You have to say I is less than, while I is less than n, or for I is less than n, continually increment I up, and then actually use I to index into the list or whatever. So um, the courses are starting to really piece things together. Um, yeah, Mahan says like how you TA for your courses in uni, so you engage with it. That's exactly, yeah, exactly. So I talked about this before. If you're in university and you're wanting like a quick tip to perform really well on your exams, and just naturally just get better at your classes and your coursework, is to get a job for the department. If you can get a job as just an undergraduate teaching fellow, yes, you kind of do already have to have some knowledge because they're not going to let someone that doesn't know anything about the topics, run some study sessions for students and get paid to do it, but through the university. But if you can kind of, manage to get some sort of networking with your professor, Try to apply for the undergraduate teaching fellow position, some sort of TA, research TA, lab TA, something, because you get paid to just basically do your homework. Like you're studying, you get paid to study, right? And just by being there, by being present in those sessions, preparing those practice questions for those students in the class, you're getting practice with the material and only getting better at those lower levels. So when I was in chemistry in my advanced chemistry courses, I was the undergraduate teaching fellow for the general chemistry course and for the general chemistry lab. So everything that I was doing in my advanced courses, I didn't have to go back into my notes and re-remember everything from redox reactions to acid-base chemistry to balancing equations to, I already said acid-base chemistry, whatever, thermodynamics to entropy. I didn't have to go back and remember all that stuff because I was just living it and getting paid to live it. Like it's such a hack in college to become a TA and get paid by the university to study. Sorry about all my hand movements. The way I see it, you coded a medium problem all from scratch, no help. This is what I call intermediate, at least for DSA/coding problems. Thanks for the advice. Well, thank you so much, Richard. I really appreciate your advice and really appreciate you joining me here and doing these problems alongside me. I often tell I don't really have any kind of relation to where I should be in terms of level. Like I don't have really like classmates or peers or something that I can compare things to. So it really is whatever you guys tell me, and you guys are really really supportive and nice. So thank you guys so much. And if you guys are new here, thank you so much for joining. My name is Michael. I'm 26. I'm a chemist. I have a degree in human biology and minor in chemistry. I have a profession as a chemist. I work for a biotech company here in the United States on the West Coast, and I've been doing that since I graduated college in 2021. But I've been teaching myself how to program after my 9 to 5 job every day for the past about 2.5 months, but about 6 months in total. Every day we've just been really on the grind here for the past about 2.5 months. So thank you guys so much for joining me here. And I have a Discord linked below where I compiled all of my study resources into one location. So you can get access to all of my live notes, projects, books, all the books you see here. I have PDF copies of the books we read live on stream, like data structures and algorithms in Python that we start the streams with every day. We are on 385 page right now. So we're making really, really good progress reading this book. Um, I yeah, so join the Discord link below and chat with me offline and everything. Sparkwave Detail, hey, how's it going? Uh, Tigrail says, I'm starting from zero basically with Python. That's why I came in. Your willingness to learn live inspired me. Awesome, dude. That's exactly what this is for. Hopefully that we can learn together here and like a peer-to-peer as if we were just like booking a room at the library and just studying together. Jay says, I was a TA for 2 first years. Yeah, we did some OCAML and some C sharp. I both love those. I love both of those languages. Yeah, being a TA is great. No, at zero, save val at zero. Okay. No, at zero, save the val at zero. At one, save val of zero times one. At two, zero, one, two. What? CS50. Okay, yeah. TA in psychology, I learn material retains about 30% x over x time, but teaching others learn material gives 80 to 90% retaining of information. Yeah, so I often say that this stream isn't it's 100% not meant to be me teaching. I am trying to learn this material myself, and if you happen to learn it alongside me, then that is so so awesome. But I was really the whole goal is this is to kind of provide comfort and that beginner point of view to show that this is what it's kind of like in a realistic approach for kind of a normal guy to try to learn this by himself, like independently after his 9 to 5 job. So in the third, stop talking in the third person here, but whatever. Yeah, so that was the main goal, and then also obviously networking and stuff. So if you happen to learn alongside me, then great. But yeah, this is awesome. Okay, cool. All right, let's shift focus here to the small business manager project for a second. We've been streaming for 2 hours and 20 minutes so far, so good stream going. So this is the project that we've been writing live on stream for the past few weeks to months. I believe we started this project back in December, so we've been working on it for a while now, little by little. So it is the largest project I've written so far. It's not crazy big. It's not crazy either. It's just basically a small business manager. I kind of explained it in the last stream, but we can load in items using kind of a script to hop between different menus that I've created, and we can load in items into inventory basically as like a inventory to sell. So for example, like clothing or things like that. We can then also load in expenses using some sort of, these menus to load in expenses when prompted to. And then that we can generate these expenses. And then overall, we have a business, that houses all of these expenses and items. And we can generate basic business information and statistics using this information. So the items have the ability to convert into just regular items, for sale items, and sold items. So we can actually generate, detect if the items are sold and generate yearly revenues based on those sales. And then we can cross-reference those hopefully with, operating expenses for these years, right? And then, produce, net income and all these various other business statistics for small business managers, right? So it's a cool project. We're not reinventing the wheel or anything, but we are taking kind of a unique, fun approach at, providing a small business owner with the ability to, manage their inventory and expenses if they don't have the knowledge to do that already. So we have a good structure here. So I'll give you guys an example of kind of what we got so far. So we can go into the small business manager by pressing yes here. And as you can see, this is kind of that menu that I was talking about where we can actually, press 1 to load in inventory. We can add items. We can find and search for items. We can view the entire inventory. We can go to transactions to actually, search for an items and transact them into, sold and for sale and sold. So this is the item that was pulled up via item number 1 that was selected. As you can see within our items.json, this item number 1 reflects what was pulled up right here from our file. So it's really cool how that works. It's all, saving on these files. And then we can convert these to, sold and whatnot. So this one actually already is sold. So if I try to do that by pressing 2 here, we actually break because I need to, I have some bugs here because remember we shifted this over from JSON format into dictionary format sorry, CSV to JSON via dictionary formatting. So we need to change this to actually be the dictionary appropriate. So so we do have some various bugs that we do need to fix for that, conversion that we did and whatnot. But we'll kind of tailor all of this up as we go here. But what I wanted to do was we need to create a function within the business.py to do something similar to the initialize revenue, but we need it to initialize for self.expenses, right? So we have expense settings here. I don't want to put it in there. Revenue. So then do I call all items, I make it, and I save the file. Tigrail, I'm the old guy in the room, but I got my associates in network and systems admin, but was hired to teach before I finished my classes. I created and taught the security curriculum back then. Awesome, dude. Security Plus, CEH, CHFI, among other certs, but I need to update everything since I've been out of the industry for a while. Well, what brings you back into the industry? Thanks for stopping in here, Tigrail. Appreciate you for coming in, bringing your wisdom here to join us. Uh, Thank you for joining me. You're awesome, man. I believe in you. You definitely can re-up those certs and get back in the game. He's back in the game. All right, so we need to go to our businesses pie. Let's go here and let's go self dot expense. Um, settings. I don't want to do settings. Expense information maybe equals to self dot equals to a dictionary. We're going to have a value of here of gross expenses, annual gross expenses. We'll set this to the initialize annual gross expenses function. Long name, but it'll be all right. So then we need to basically do something similar to this guy up here. So I'll just put this here for now. So let's go def initialize annual gross expenses. Right, I'm taking self. So we're gonna have we're gonna return a dictionary. So annual gross expenses equals to a dictionary. We're gonna say for. So in our expense, we have expense number and expense as the item, right? So a similar setup to the revenue. So for expense number and expense in self dot expenses are all expenses dot items, right? So this method will break apart the keys and values within this dictionary, and so we can access each one of them. And so we're only really care about the actual expense, right? So we'll say in our expenses JSON. So we want to say if amount, which they should already have basically, right? It should always have an amount, but we'll just do a check. So if amount. So we'll say, we'll go if expense, quote, amount, right, which will return a Boolean. For an amount, we will try to do the following. Go expense, annual gross expenses, expense, quote, date, right? And we're going to slice the first 4 characters from this date. Plus equals to expense. We want the amount here. Right. Except if we get a key error like above, meaning that this key does not exist, we're going to initialize the key inside of the annual gross expenses dictionary as the expense, quote, date, and we're going to slice the first 4 again. But instead of saying plus equals, we're just going to set equal to item, quote, amount, like so. not item, sorry. Expense. Okay, so that will essentially, and then we will return annual gross expenses. So now watch what happens, you guys, with our business JSON here. If I delete, no, if I just run, right, and I go yes, as soon as I press yes here, what happens? Oh yeah, we need self. So if I press 1 here, as soon as I press 1, what happens to my business file? Nothing. um, oh, we need to add it here. So then what happens if I delete the file and then bring it back in? So business is pi. Self.expense information. So why is this not saving that new information? So we initialize annual gross expenses. We return the expenses found in 2025. So then what happens if I go into here and I say print business dot expense information? Aha, it's there. It's just not saving. Business.expense information is equal to, quote, gross annual expenses So we need to save the expense information. So I'm saving expense settings, expense information. Quote. $1.25? What? What's 1.25? I'm talking about 1.25 subs? Yeah, we're at 1.25 right now, which is awesome. Okay, so that is giving me that now. So if business JSON, we load, we read off of here, set here into here, that value there. Expense methods. Let's go back. Um, shoot. Whatever. Yes. What's going on here? Why? I'm lost. So I'm calling business.expense information is equal to annual gross expenses. Expense settings. What's going on here? Why can't I follow what I wrote? Why can't I follow what I wrote here? So if we find content on the business file, JSON file, we load the name, all items, business.expense information. gross expenses. Why can't I figure this out? Where do I have this bug? Expense, revenue. Revenue. Expense categories. Expense methods. So let me delete this. Over here. Yes. There we go. No. Shoot. Hey, Gina. How are you? Yes. How did I get in before? Oh, because I didn't have the file. Alright, so annual gross expenses is there. Annual gross expenses, quote. Thanks, Gina. So business, we have. Oh, but I'm not saving revenue here. It happens automatically. Right, in my business pie, expense information gets uploaded automatically on initialization. So then don't even think I need this. It'll generate automatically, which it does. So then how can I get this to save? So I need to add it to my save. Save file. I dump business to dict. So business to dict. Here. Okay. Quote. Expense information. List equals equals information. Done. So now if I run, yes. Boom, there it is. Boom, there it is. Boom, there it is. Oh, there it is. Wait, so why is this a dictionary of dictionaries? Oh, okay. So then in my business's pie, we'll have self dot income information equals to a dictionary where we have quote revenue and self dot initialize revenue like that. And then in the save as, then we're in the initialize revenue, update revenue, item sold price, income information, quote, revenue. Key year amount. That. And then that. That. Okay. So now if I run, we should see this convert over into a dictionary of dictionaries called it's called income information revenue. There you go. Boom. All right, cool. So now we have a dictionary of income information where we can house revenue, net income, yada, yada, yada. So we can keep adding. We have gross annual expenses. We can sort expenses by category, right, within this as well. So we can initialize category by category. We can do it. We can do that, all that. So it'll be really, really cool. So now we can house multiple information within this information of income and expense. Awesome. So then maybe I should house these in there. All right. If you guys are enjoying the project so far and enjoying hanging out with me, feel free to leave a like on the stream. It really, really helps to keep YouTube promoting it and picking us up and suggesting us to people and keeps our community growing. Thank you guys truly, truly for joining me here. We've been growing quite rapidly. We're already at 1.25K, so we're gonna be at 1.5 soon, and then 2K. Nonetheless, we're just keep growing here, you guys. You guys are really, really awesome. I honestly I can't thank you guys enough. Okay, so then let's make sure that that is appropriate. 11,600. So in our go expenses JSON 75, 85, 86, 96, 11.6 or 10.6, 11.6, 11.6. Perfect. So that's doing the adding correctly then. Nice. So then let's go here. Let's go to our main. Let's go yes. Let's add an expense. Use a different date. Let's use from 2024-10/31 Halloween. Expense was, let's say it was $1,000. Description, test expense. Category, let's say it was inventory method, new method, test method. Note, no note. So boom, right? That we have our expense that got updated right there, test expense. We have businesses JSON now that got updated for so then we need to so test method got updated there live. So we don't have any way of actually, we initialize these, but we don't actually update these at all for any, unless we relaunch. So if I go main yes, which that does the initialization, yes, you should see this number, you should see a 2024 get added onto here. Yes! So cool. It's so awesome when things work out how they're supposed to. Woo! So remember, guys, this is, it might look, I said 1,000, but this is coming in at 100,000 because I'm converting the whole US dollar to US cents, CENTS, cents. Because I'm keeping things in whole integers rather than using floats, so I don't have to deal with rounding issues. So I'm converting, dollar inputs into cents and then reconverting those back out into dollars. Awesome. So that takes care of that. So maybe next time we'll insert the expense categories and methods inside of the expense information. Yeah, if we go expense information, and we just take expense settings here in its entirety. Expense settings. Why am I converting stuff already to a list? I don't need to do this. It's already a list. Should still work. Let's go to settings, expense settings, add category, quit, add method, quit. Okay, perfect. All right, and then we can get rid of that print statement for that debugging. Nice. Cool, so now we have it. Where we have, now we have gross annual expenses being generated. So if I go update revenue, if I make a sale, so transact item, if I make a sale, I call update revenue here on the sale. So my update revenue function okay, we'll actually go and update it. So I need to have it update expense. Then so I can have it do it live. Okay. So we need an update. Let me take this function here. Just gonna put it up here. Like that. Okay. And now we need to do def update annual gross expenses, right? Update revenue here. Expense. I try to get the year from expense. Cap's gonna take this entire function then. Like that. Update expense. Try year's expense. Dates or date. Expense. Has no date. Amount equals expense quote amount. If amount is less than 0, amount is none. Raise value must be positive integer. Year in self dot so it's not update revenue. It's gonna. I need to change this then. Oh, I did. If year in self dot income information revenue dot keys self dot expense information quote annual gross expense keys self dot expense annual gross expense like that there okay. So then we go here on add expense right, and then here we're going to go shoot, what did I just say? update expense, business dot update annual gross expenses with the new expense. All expenses. Yeah, we set the item number. Get details of the new expense. Cooking low, SS low. Yeah, we're cooking here. Feeling good. We're adding a lot of stuff here. We're moving. I'm about ready to wrap it up here, though. I'm getting a little pooped here on my Friday, and I want to spend some time watching a show with my dog here. She's been needing some attention. Huh, Sky? Huh, Sky? Huh? She's sleeping. Okay, we call business. So then, what about for transact? I call business dot update revenue. Why am I calling? I call business dot update revenue on this instance. Not a class method. This instance method update revenue. Update annual gross expenses. So then if I go here, main, run, I go business.py here, or sorry, JSON, you should see this number change. So if I go expenses, add expense, use today's date, yes, amount, let's say it's really big. Dang it. $9.39 of businesses.py. Why am I able to? Why am I able to call item quote sold price here? So my transact item. Update revenue on the item. Item quote. This is transact item. Save. Hmm. Should work now, I think. No. So line 507. Update annual gross expenses. If year in okay. So I need to convert the expense into a JSON object or save the file and then pull back up that expense number. So if I go here, I save the file, I call new expense is equal to all expenses oh shoot, all expenses, what's going on here? So I save the file, I need to pull back that expense out of the file that we just saved. No. Because when you add it, how to convert a object to a JSON object. JSON.dumps passing the object as the argument. JSON.dumps new expense. So then if I go back to here and I do amount here, expenses, add expense. Shoot. Okay, it's not serializable. So what do we business? Decided gross expenses. I just gotta do it by dot date then. Dot amount. If I run that back, that like that. If I run, yes. What is happening? What's that print happening? Yes, so let's go to businesses pie here, business JSON, sorry. Expenses, add expense, yes. Big number. Oh, shoot. Key error, annual gross expense. If year. Expenses. Expenses. Yes. Expenses, add expense, yes. Over here. Expense note should be none. Oh, that didn't do it. Dang it. Update. This is JSON. Annual gross expenses. So then if I go launch this again, it'll update. So it's not updating live when I make the expense. Why? Why is it not updating here? On business. Oh, because we're not saving the business file either. Save file. Type equals quote business.json. Yes. Expenses. Add expense. Yes. Amount. Let's say it's 99999. Yes. All right. That worked now. Main menu. Exit. Yes. So if I bring this, go to our expenses.json. Let me go ahead and remove a few expenses. Some of these bigger ones. So we can see this happening. We remove all but the first one, so we should have only $7,500 in expenses when I load this. Yes. Businesses.json, 7,500. Yep. Okay, if I go expenses, add expense, yes. Amount, 500. Let's go 9999. Description, yes, yes. No note. Sweet, that got updated. 9999 plus. $9,999 plus $75 equals $10,074. Perfect. 0 cents. Gotcha. Now if I go add expense, use today's date, no, 2024, 10/31, amount 8, let's say $100. Inventory, test method, no note. Boom, that got updated. Now if I go add expense, today's date, or no, not today's date, amount 1, description 1. Add expense, no, 10, or 2024, 10/31, amount of, let's say 500. Now you should see this number change if it works appropriately for detecting our other years. 1, and yes! Woo! Sweet. All right, so now we have our expenses. When we add a new expense, we're updating the expense and saving the file right away. And then when we add items, we're also doing that as well. So the same thing is happening. So we just need to add that update and saving to the actual search then as well. So Command C, so find edit expense, right? If they press 7, we're going to do this. Update with the expense that we're currently on. But this is pulling that from the data. Ah, shoot. So this is where we have a problem. Right, because this function is trying to access expense.amount and stuff, but expense amount is being saved within the dictionary here because we're pulling these up out of the database. Okay, we'll have to deal with this some other time. I'm not going to deal with it now. Okay, that's fine. Bro, still went live. I went away for a bit, just got back after turning on my PC and clicked on the link, and you're still live. Keep up the grind, Mike. Hey, thanks you, man. I appreciate you, Script Serpent. I got a question for all viewers. Pepsi, aka Coke, Dr. Pepper, Mountain Dew, as well as Taco Bell, McDonald's, Wendy's, Arby's, or Sonic. In terms of soda, I go Coke over Pepsi. I'll take a Coke over Dr. Pepper. And I'll also take a Coke over Mountain Dew. I'll take a Dr. Pepper over a Pepsi. I'll take a Dr. Pepper over a Mountain Dew. I'll take a Mountain Dew over a Pepsi. And a Pepsi is last. Taco Bell, McD's, Wendy's, Arby's, or Sonic. I'll take Oh, I'll take Wendy's number one. No, I can't. Wendy's has gone downhill. I'll take Taco Bell as number one. I'll take Wendy's as two. I'll take McDonald's as three. No, I'll take Arby's as three. McDonald's four. No, I'm sorry. I take that back. Taco Bell one. Sonic two. Wendy's three. Arby's four. McDonald's five. That's my ranking. So I'll go Coke, Dr. Pepper, Mountain Dew, Pepsi, and I'll do Taco Bell, Wendy's, Arby's, Sonic, McD's. Diet Dr. Pepper. Richard says, "All right, I'll see your point. I see your point. Ask ChatGPT to give me a bunch of for loop practice with just one step above the absolute basics. It looked a lot like what you were doing in the code problem earlier. Thanks again. This is where I need to be. Time for a ginger ale." Yeah, awesome. I'm about to grab myself a drink too. Kind of wrap things up for tonight. We streamed for 3 hours and 21 minutes tonight. Hey, Time, welcome. How's it going? Welcome in. I appreciate you guys for joining me. If you guys are new, my name is Michael. I'm 26 years old. I have been programming for and coding and teaching myself for about 6 months now. I have a degree in human biology and a minor in chemistry. I work as a formulation chemist in a biotech company, and I have been doing that ever since I graduated college. But I've been just teaching myself Python for about 6 months. Trying to learn computer programming, learn computer science. Right now, we're taking Harvard CS50X live on the channel, as well as reading some material from data structures and algorithms in Python, doing live projects, live reading, live courses. So if that's something that you're interested in following along for a beginner point of view, an authentic kind of grinding through this without sugarcoating things, then please follow along. And then also I have a Discord linked below where you can you get access to all of the materials you see, from PDFs of the books to the notes on my screen to the projects to CS50X information. I post weekly recaps for my problem sets in there. So please join the Discord, and please follow along to the channel if you're enjoying the content so far. I really like hanging out with you guys on a daily basis. I stream every single day around 7 p.m. PST, and on the weekends I'll come on a little earlier in the afternoon or the morning to help break it up and help get some of the East Coast and international folks in here. In and Out clears all of those places. Yeah, I agree. In and Out above all. I would go Dr. Pepper, Coke, Mountain Dew, then Pepsi, and then I would go McDonald's, Wendy's, Sonic, Taco Bell. You take McDonald's first? Ooh, I would take McDonald's first 7 years ago. 7 years ago, McDonald's was just premium. Like when I was in college, I remember just the value menu, the McValue menu, and just late night at like 2 in the morning. They were all open 24/7. They all were cheap. Now it's just you can honestly go to like Chipotle for the same price and get 2 times the amount of calories per protein per fat. Um, and it just and for some reason I think they've changed their meat, but I can't eat their burgers anymore. They legit make me sick like the next day. I don't know what it is with their food, but it's gone real downhill in my opinion. They've changed something with their meat because it is different in my opinion. All those fast food, of which the best fries in your opinion? Best fries in your opinion? Uh, I will say the best fries probably does have to go to McD's. They do win the fry front. Oh, I will add Arby's curly fries, game changers. Those are good too. No worries. All right, you guys. Thank you guys so much for joining me today on the February the 7th, 2025. This was a great Friday. So if you're with me programming on a Friday, then pat on the back to yourself. You're working on yourself, your own education, improving your abilities, and your skills. So I appreciate you guys for joining me today. I'll be back tomorrow to stream more content where we'll be diving back into Harvard CS50X Week 5 for the Week 5 problem set in C. So if you're wanting some, to take that course with me and get some exposure to see what it might be like, I'm currently about halfway through the course. I've been documenting my progress this entire time and uploading. I've been streaming the lectures, I've been streaming the problem sets, and I've been re-uploading the condensed versions of those streams onto my channel. So if you guys want that content, then go look it up on my channel and you go check it out. But I will be back tomorrow where we will be diving in back into CS50X and going over the problem set for week 5 and completing it tomorrow. So I'll see you guys tomorrow. Thanks so much for coming in. Scripts are also agreeable, but Chick-fil-A are also bomb. Yeah. I'm new to Python. Please suggest how to start and what please suggest. Yeah, time. Please join my Discord. I provide a lot of beginner resources in there, and it's a great opportunity to follow some courses. I highly suggest you take Harvard CS50P or CS50X, which I'm currently taking right now. My first introduction to programming was Harvard CS50P, and then I paired that with the Python crash course book you see behind me. So you can get this in my Discord, and as well as a lot of other information regarding Harvard CS50 X and P in my Discord. So I'll see you guys tomorrow. Thanks so much for joining me tonight. I do not speak Russian. I am American through and through here. Richard, thanks so much for coming in. It was awesome talking to you. Script Serpent, thanks for coming in. Time, Tigrail, thank you so much. SS Low, you're a beast. Gina, Mahan, you're awesome, man. Thanks for coming in. Jay, thanks for coming in. Trash, Ryan, you're awesome. Magnet, JT Oits, appreciate you for coming in. You're awesome. You're great. Zanab, you're great. Welcome. Hello. Thanks for coming in. Shashant, you're awesome. Thanks for those suggestions during Leak Code. Nugs, you're awesome. Dos Santos, welcome. Murad, appreciate you for joining me. JP, you're awesome. The review, Owen. All right. Anyways, guys, I'll see you tomorrow. Thanks so much for joining me. Message me in the Discord if you want to chat. I might hop in there a little later, but it's getting kind of late, so I might have to call it for tonight, and we might have to come back tomorrow. So I'll talk to you guys later. Yeah, Ty Grail, if you have some resources, throw them in the Discord. I have a community resources tab within the general section where you can just create a thread and throw in some resources of your own. If you want to suggest some stuff that you found helpful, feel free to throw it in the community resources or throw it in the chat or whatever. So thank you guys so much for chatting with me. I'll be in the Discord for the rest of the evening. See you guys.